Hello everyone. In this lesson, I'll complete solving the exercises of lesson 4.1. We reach question number 18. Find the critical point, maximum, increasing and decreasing interval, maximum local and minimum extremum for this function. F of x equal x to the power 2 over 3 minus 4. First, we find the critical point by differentiating this function f prime of x equal 2 over 3 x to the 2 over 3 minus 1 negative 1 over 3 minus 0. Set it equal 0 and solve to find x. 2 over 3 cube root of x equal 0. Then cross multiplication, 2 equals 0, contradiction, there is no value, make the derivative of this function 0. But this the derivative is undefined and 0 at 0 and 0 is within the domain of this function, then x equals 0 is critical point. To find the interval of increasing and decreasing, find the sign of the derivative at before and after the critical point. Before 0, take negative 1, 2 over a cube root of negative 1, 2 over negative 3 negative. Value when x greater than 0, then take 1, 2 over 3 times cube root of 1, positive value. Then the function here is decreasing, here increasing, then the interval of decreasing is negative infinity to 0, and the interval of increasing is from 0 to positive infinity. 0, the point 0 with the negative 4 is local minimum extremum for this function. Question number 19. Find the critical point, increasing and decreasing interval, maximum and minimum local extremum for this function. Redefine this function as f of x equal to piecewise function 5 minus x minus 5 when x greater than or equal 5 plus x minus 5 when x less than 5. Since the absolute value of x minus 5 is x minus 5 when x greater than or equal 5, negative bracket x minus 5 when x less than 5. Now differentiate this function f prime of x equal to negative 1 when x greater than 5, 1 when x less than 5, and the limit when x approach to 5 from left not equal to the limit when x approach to 5 from right, because from left is 1, from right is negative 1. Therefore, the function is not differentiable at 5. Therefore, 5 is critical point for this function. Find the value of the derivative before and after 5. When x less than 5, the function is 1, positive. The derivative of the function is positive. When x greater than 5, the derivative is negative. Then the interval of increasing is from negative infinity to 5, is the interval of increasing, and from 5 to positive infinity is the interval of decreasing. 5, find the y coordinate of 5, substitute 5 in the function, 5 minus 5, 0, then 5, 5 is local maximum point for this function. Question number 20, f of x equal x plus 1 over x. Find the derivative of this function, f prime of x equal to derivative of x1. Derivative of 1 over x is negative 1 over x squared. Since 1 over x is x to the negative 1, its derivative is negative x to the negative 2 equal to the negative 1 over x squared. Now, set the derivative 0 and solve to find x. 1 over x squared equal 1. Then x squared equal 1. Then x equal to negative positive 1. Find the interval of increasing and decreasing by finding the sign of the derivative before and after the critical point. When x equal negative 2, then negative 2 power 2, it is 4. 1 minus 1 over 4, it is positive value. When x is 0, the derivative is undefined, but 0 is not within the domain of the function. Then 0, x equals 0, not a critical point, but we will find the value of the derivative before and after 0 when x equals negative 1 half, negative 1 half square 1 over 4, 1 over 1 over 4, 4, 1 minus 4, negative 3. When x equals 1 half, 1 over 1 half square 4, 1 minus 4 also negative 3. When x equals 2, 1 over 4, 1 minus 1 over 4, it is positive value. Therefore, this is the interval of increasing and decreasing. From negative infinity to negative 1, union from 1 to positive infinity, those are the interval of increasing, and from negative 1 to 0, union 0 to 1 are the interval of decreasing. The critical point, negative 1, substitute negative 1 in the function, negative 1 minus 1, 0, negative 1 minus 1, negative 2, it is a local maximum point since the function changed from increasing to decreasing, and 1 plus 1, 2 is a local minimum point since the function changed from decreasing to increasing. Question number 21. F of x equal x power 2 over x power 2 minus 9. Find the derivative of this function, f prime of x equal to the denominator x power 2 minus 9 times the derivative of the numerator 2x minus the numerator x power 2 times the derivative of the denominator 2x over denominator square. Simplify this derivative, f prime of x equal to 2x times x power 2, 2x power 3, 2x times minus 9 minus 18x, x power 2 times 2x minus 2x power 3 over x power 2 minus 9 square, minus 2x power 3 with positive 2x power 3, then negative 18x over x power 2 minus 9 power 2 equals 0. Cross multiplication, then negative 18x equals 0, then x equals 0 is critical point for this function. And the derivative is undefined at 3 with negative 3 because they make this value makes the denominator 0, but 3 and negative 3 are not in the domain of this function, so the only critical point is a 0. To find the interval of increasing and decreasing, find the sign of the derivative before and after the critical point 0, here 3 and here negative 3. Before negative 3, negative 4. The denominator is always positive. Negative times negative positive. So here is positive. Between negative 3 and 0, take negative 1. Negative times negative, also positive. Between 0 and 3, take 1. Negative 18 over 1, negative value. When x greater than 3, take 4. Negative 18 times 4, it's negative value over positive negative value. Then the function is increasing in this interval, decreasing in this interval. Therefore, the interval of increasing are negative infinity to negative 3, union negative 3 to 0. Those are the function, the interval of increasing. And from 0 to 3, union 3 to infinity to positive infinity are the interval of decreasing. The only critical point is 0 by 0 over negative 9, 0. 0, 0 is a local maximum point since the function changed from increasing to decreasing. Question number 22, f of x equal x power 2 minus 2x plus 1 over x plus 1. Find the derivative of this function. The denominator x plus 1 times the derivative of the numerator 2x minus 2 minus the numerator x power 2 minus 2x plus 1 derivative of the denominator 1 over denominator square. Simplify this derivative, f prime of x equal to 2x times x, 2x power 2, 2x times 1, 2x, negative 2 times x, negative 2x, negative 2 times 1, negative 2, minus x squared plus 2x minus 1 over x plus 1 power 2 equal to 2x minus 2x 0, 2x power 2 minus x power 2 x power 2 plus 2x minus 3 over x plus 1 square. Set it equals 0, cross multiplication, then x power 2 plus 2x minus 3 equals 0. Analyze by experiment, x, negative, then negative, positive, 3, 1 equals 0. Either x equal 1 or x equal negative 3 are the critical point of this function. Find the interval of increasing and decreasing by finding the sign of the derivative of this function. Negative 3, negative 1, 0, 1. Since the derivative of this function is undefined at negative 1, we take negative 1 also in the number line, but negative 1 not in the domain of this function, so negative 1 is not a critical point of this function. Before -3, take -4. -4 square, it is 16. 16 minus 8. 8 minus 3, positive value. Since the denominator is always positive. Between -3 and -1, take -2. -2 square, 4. 4 minus 8. Minus 4 minus 3 minus 7, it is negative value. Between -1 and 1, take 0. 0 plus 0, 0 minus 3 minus 3, then the value is negative. When x greater than 1, take 2. 2 power 2, 4 plus 4, 8 minus 3, 5, it is positive value. Therefore, the function here is increasing, here decreasing, and increasing, and from 1 to positive infinity. From negative infinity to -3, union from 1 to positive infinity, those are the interval of increasing, and from -3 to -1, union from -1 to 1, those are the interval of decreasing. And the point -3 by substitute -3 in the function to find y coordinate. -3 square, 9. -3 times -2 plus 6 plus 1, 16 over -3 plus 1, -2, then -8 is a maximum local point for this function. And the point 1 by 1 minus 2 minus 1 plus 1, 0. 1, 0 is local minimum point for this function. Question number 23, f of x equal x over 2 plus cosine x. In the interval 0 to pi, find critical point, increasing and decreasing interval, maximum and minimum local point, extremum. F prime of x equal to x over 2, it is 1/2 minus sine x, the derivative of cosine x, set it equal 0. Then sine x equal 1/2, then x equal sine inverse 1/2 equal to pi over 6 from the calculator. The sign is positive, then the sign is positive in quarter 1 and quarter 2. In quarter 1, x equal pi over 6, and in quarter 2, x equal pi minus pi over 6 equal to 6 pi minus pi, 5 pi over 6. This is the two critical points. Find the value of the derivative before and after these 2 points. This is pi over 6. This is 5 pi over 6. Substitute any value less than pi over 6 in the derivative of this function. You will find that the sign is positive, since sine pi is 0 and 1/2 minus 0 is positive. Between pi over 6 and 5 pi over 6, you will find that the value of the derivative is negative. Greater than 5 pi over 6, the sign is positive. Therefore, the interval of increasing are from 0 to pi over 6 open interval union 5 pi over 6 to 2 pi. Those are the interval of increasing, and from pi over 6 to 5 pi over 6 open interval, it is the interval of decreasing. The point pi over 6 with pi plus 6 square root 3 over 12, it is local maximum point for this function, since the function changed from increasing to decreasing, and the point 5 pi over 6 with 5 pi minus 6 square root 3 over 12 is a minimum local extrema for this function, since the function changed from decreasing to an. Question number 24, f of x equals sine x cosine x. The derivative of this function is the first function sine x times the derivative of the second function negative sine x plus the second function cosine x times the derivative of the first function cosine x equals 0. Then cosine square x minus sine square x equal to 0. Then cosine square x equal to sine square x. Then sine square x over cosine square x equal 1. Therefore, tan square x equal 1 and tan x equal negative positive 1. And x equal tan inverse 1 equal to pi over 4. Tan x equal negative positive 1, there we will take it in the fourth quarter. In the first quarter, x equal to pi over 4. In the second quarter, x equal to pi minus theta pi over 4 equal to 4 pi minus pi 3 pi over 4. In the third quarter, x equal to pi plus pi over 4 equal to 4 pi plus pi 5 pi over 4. In the fourth quarter, x equal to pi minus pi over 4 equal to 8 pi minus pi 7 pi over 4. Find the interval of increasing and decreasing. Set the critical point on the number line, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Find the sign of the derivative before and after this point. Before pi over 4, the sign, you will see that the sign is positive between pi over 4 and 3 pi over 4. Negative between 3 pi over 4 and 5 pi over 4, the value is positive. And between 5 over 4, 5 pi over 4 and 7 pi over 4 is negative. Greater than 7 pi over 4, the sign of the derivative is positive. And the interval of increasing and decreasing are, for the increasing interval 0 to pi over 4 open interval union 3 pi over 4 to 5 pi over 4 union 7 pi over 4 to 2 pi. Those are the interval of increasing. And the intervals of decreasing from pi over 4 to 3 pi over 4 union 5 pi over 4 to 7 pi over 4. Those are the interval of decreasing. And the point pi over 4 by half is local maximum point for this function. 3 pi over 4 with negative 1 half is local minimum point. 5 pi over 4 with a half is local maximum. And 7 pi over 4 with negative 1 half is local minimum. Number 25, f of x equal cosine square x in the interval 0 to 2 pi, f of prime of x equal to 2 cosine x times the derivative of the cosine negative sine x equals 0. Then negative 2 sine x cosine x equals 0. Divide by negative 2, then sine x cosine x equals 0. From the graph of this function, this is the graph of the sine, and this is the graph of the cosine. The value makes sine 0 in this interval is pi. The value make cosine 0 are pi over 2 and 3 pi over 2. Therefore, we have 3 critical points make sine and cosine 0 in the interval 0 to 2 pi. Find the sine of the derivative at this point, pi over 2, pi, and 3 pi over 2. Before pi over 2, both cosine and sine are positive. Positive times negative 2, it is negative value. Between pi over 2 and pi, the sine is positive and cosine is negative. Positive times negative, negative times negative, positive. Between pi and 3 pi over 2, both sine and cosine are under x-axis are negative. Negative times negative, positive times negative, negative. The value of the derivative when x greater than pi over 3 pi over 2, the cosine is positive and sine is negative. Positive times negative, negative times negative, positive. Therefore, the interval of increasing and decreasing are from 0 to pi over 2 union from pi to 3 pi over 2 are the interval of decreasing, and from pi over 2 to pi union 3 pi over 2 to 2 pi are the interval of increasing. And the point x equal pi over 2 is local minimum extremum for this function. X equal pi is local maximum for this function, and x equal 3 pi over 2 is local minimum extremum for this function. Question number 26. F of x equal sine x over 1 plus cosine square x. Find f prime of x to find the critical point. F prime of x equal to denominator 1 plus cosine square x times the derivative of the numerator cosine x minus the numerator sine x times the derivative of the denominator 2 cosine x times negative sine x over denominator square. Simplify this derivative. Cosine x factorized by cosine x for the two term in the numerator. 1 plus cosine square x plus sine times sine square 2 sine square x over 1 plus cosine square x all square equal to cosine square cosine x 1 plus cosine square x plus 2 sine square x equal to 1 minus cosine square x. So substitute 1 minus cosine square x instead of sine square x. 2 times 1 minus cosine square x over 1 plus cosine square x all square equal to cosine x 1 plus cosine square x plus 2 minus 2 cosine square x over 1 plus cosine square x equal to cosine x times 1 plus 2, 3 minus cosine square x minus 2 cosine square x minus cosine square x over 1 plus cosine square x all square. Set it equals 0, cross multiplication, then cosine x times 3 minus cosine square x equal 0. 3 minus cosine square x never been 0 because 3 minus cosine square x equals 0. If we set it, then cosine square x equal 3, then cosine x square root both sides equal to negative positive square root 3 equal to 1.37. But cosine its range between negative and positive 1, then there is no value of x make the cosine 1.37. Therefore, we have only cosine x equals 0, then x equal cosine inverse 0 equal to pi over 2 and 3 pi over 2, because the graph of cosine is this shape. This is pi over 2, the value make the cosine 0, and this is 3 pi over 2, the other value make cosine 0 in the interval 0 to 2 pi. Therefore, we have two critical points. X, find the sign of the derivative at before and after these two critical points to find the interval of increasing and decreasing and local minimum and maximum point. If we see the derivative of this function, the denominator is always 0, always positive, sorry. 3 minus cosine square x always is positive because sine x is between negative 1 and positive 1. Therefore, the sign of the derivative depended on the sign of the cosine x. When x less than pi over 2, cosine is positive over x-axis. When x is between pi over 2 and 3 pi over 2, the graph is under x-axis, so it is negative. When x greater than pi over 2, less than 2 pi, the graph is over x-axis, then it is positive. And the interval of increasing, this is the interval of increasing, and this is the interval of decreasing. Let us write it here. From 0 to pi over 2 union the interval 3 pi over 2 to 2 pi. These intervals are the intervals of increasing, and the interval pi over 2 to 3 pi over 2 is the interval of decreasing. And the value, the point pi over 2, 1, if we substitute pi over 2 in the function sine pi over 2, this is sine pi over 2, it is 1 over 1 plus cosine pi over 2, this is cosine bar, it is 0, 1 over 1, 1. Then pi over 2, 1 is local maximum point because the function changed from increasing to decreasing, and 3 pi over 2 is negative 1 is local minimum point for this function. Question number 26 to 29, identify whether the function has local minimum point on the interval a and b. For the question 26, the function has local minimum point in the interval a or b at this point, because this point is a sharp vertex point for this graph, and this point is a critical point, and the function changed from decreasing to increasing. Therefore, the function has a local minimum point at C. For question 27, the function has local minimum point at this point because this point belongs to the domain of this function, and the function changed from decreasing to increasing. Therefore, the graph of the derivative of this function intersect with x-axis at this point. Therefore, the function has a local minimum point at C. For question number 28, the function has no local minimum or maximum point because the function is decreasing from A to B, and there is no critical point in this interval. Question number 29, the function also has no minimum point because the function has a local minimum point in this point, and this point is not in the domain of the function. Therefore, the function has no local minimum point in the interval A and B. See you next lesson.